Hello everyone. Today we are going to solve GFG problem of the day. Maximum sum rectangle. So let's see what the problem says. So in the problem we have been given a matrix, and in this matrix we have to find the rectangle whose like whose sum is maximum. So it can have many rectangles among it. This is one, this is one, this is one, and among them this green part that is highlighted, that is the maximum. So we have to return whatever sum it is holding, and that would be our expected output. So here, let's consider its brute force approach, and brute force is find all all of it rectangles. One starting from here, then this, then this, like all the rectangles. Keep finding all the rectangles, and keep summing, and in the end return the sum. What would be the time complexity? So this overall matrix is n cross n. So n cross n is the matrix, and every time if we consider from here, then from here to here, every time we are again running n into m in the map, like in the matrix, and in after that if we do the sum, like we if we don't store the sum anywhere, then again that would be n into n. But if we, let's say, if we store the sum anywhere, and like something like prefix sum, so we can neglect this n into m part, and the worst case time complexity will be n into m square, n into m whole square. So that would be my time complexity of brute force approach. But let's see if we can try to optimize it. So let's consider only this part, only this. So let me add it. Let me make an array. Let's say I have an array, and I have only this part stored somewhere. 1 minus 8, 3 and 4. And let's say I am making a sum variable that is initialized to 0. So if you see in this part, what would be my maximum sum? So my maximum sum in this part, if you see, would be this 3 only. Okay. So let me update my sum to this 3. And what would be giving me this maximum sum? So maximum sum in subarray we can find using Codey's algorithm. So Codey's algorithm, if you already know, it is able to give us the maximum sum in a array, like longest subarray in array. So let's say in this part 3 is maximum. So what I want to do is I want to find this whole part. Like till now I have only this part. Now I want this part also considered in this one. And then I want to find the max sum. How I can do that? So if I say this part is there and I want to apply its effect in this one, how can I do that? Let's, if I can add this part in this one, and if again then I find sum, would it give me the maximum sum? Yes. So I apply this part in this one. What we have to do, just sum it. So 1 plus 2, that is 3, minus 8 minus 3, that is minus 11, 3 plus 8 plus 11, and minus 4, like minus 4 minus 1, that is minus 5. So what I did, I have considered this whole part's effect in my this 1D array. And now if you see, the maximum is, it is saying 11, that is lying in third row. So if you see among this is the maximum. So in these two, if you see, this is my maximum sum. So what we did is till now we have considered this part and the maximum is 11. Since maximum that 11 is greater than whatever we are storing in sum, so we will update us. Now I want to apply this part's effect in this one. So just do nothing, just add this and then find maximum. So 3 minus 1, that is 2. Now minus 11 plus 4, that is minus 7. 11 plus 10, that is 21. And minus 5 plus 1, that is minus 4. So what I did, till earlier point we had this part. Now I have applied its effect in this one also. So now the maximum sum that I can find is, I will find the maximum sum using Codey. So that is 21, and since that 21 is greater than 11, I will update my sum. And if you see in this combined part, if it is saying 21 in this row, that means if we consider only this part, among them, this part's sum is maximum 21. So this is our maximum sum. And you may also ask question, this whole part aren't we considering? So we are considering. That is being taken care by our Codey. So if our whole part sum was maximum, our Codey would have returned summing all of this and it would have returned. So till this point we have taken. Now I want to apply this part's effect in this one. So just nothing, sum it, apply Codey. 2 minus 4 minus 2 minus 7 plus 2 minus 5, 10 plus 1, oh sorry, 21 plus 1, 22, minus 4 plus 7, that is plus 3. So now if in this part I want to find, like from starting I have applied effect till this point, and in this part I want to find the maximum. So the maximum that is coming 22 plus 3, that is my 25, and since my 25 is greater than 21, I will update my sum. So in till this part, the maximum sum that we are getting is, so if this part is saying the maximum sum, so in our original array, this would be that part, this, that is giving me maximum sum. So till now we have considered till this point. Now let's apply the last rows effect. So here, if we apply this rows effect in this, we will get the whole matrix maximum, like starting from this point. So minus 2 minus 20 minus 22 minus 5 plus 1, that is nothing, minus 4, 22 plus 3, that is 25, and 3 minus 6 is minus 3. So what I did is, from starting I have considered all matrices that can be formed. This I have considered, then this I have considered, and then starting from this I have considered, then starting from this point this I have considered, and now this also I am considering. So among these, the maximum sum that we can get is 25, that we can get from Codey. And if we see 25 is already we have, we will not update our sum. But what is this 25 is saying? If we find this 25 in this row only, that means this part is giving me the maximum sum. So what I did is, I find all of the matrices sum that we are starting from this point. But what about this? What about starting from this point? What about starting from this point? So to consider, again I will start from this point, and then I will keep considering this, keep considering this, keep considering this, keep considering this, Now again I will come here and I will start from here. I will again starting considering from this point, whatever is being started from this point, from now this again, like after completing all of it, again I will come here. I will consider all of it starting from this point. So let's traverse for like starting from this point, because in this case we are going to get our maximum. So at starting, if you see, we have 2 minus 3, 8 minus 1. So let's update it. 2 minus 3, 8, and then minus 1, right? Because we are starting from this point. Now, if you see the maximum here, what we are getting is only 8. So, since my 8 is smaller than my sum, I will not even consider. Now, this point is done. Let's add this point's effect in this one and have it combined like this whole. So, 2 minus 1 is minus, like 2 minus 1 is plus 1. Then minus 3 plus 4 is again plus 1. 8 plus 10 is 18. And minus 1 plus 1 is 0. So the maximum here, what I can get is this part. Or we can also add this part, but let's say only this part. Because this is 0, this is doing nothing, so we can also add 18 plus 1, that is 20. So my 20 is smaller than sum, we will not update sum. But what it is saying is, in this part, we have one matrix that is maximum. So now we have considered starting from here till this parts effect. Now let's apply this part effect, because in this, if you see, this is the maximum we are going to get. So in our array, last three sum should give us like maximum. So let's see. Minus 1 minus 4, that is minus 3. 1 plus 2, that is plus 3. 18 plus 1, that is 19. And 0 plus 7, that is 7. Okay. So now what I did, I am considering this whole. So if you see 19 plus 7, 26 plus 3, that is 29. And it is coming in this part, that is saying, starting from this point, I have one matrix. Like starting from this point, if I am considering this matrix, I have one matrix in which this point is giving me maximum. So I will check, since my sum is storing 25 and I am coming up with 29, I will update my sum. Next again I will add this point and so on. So starting from this we did it. Now starting from here we will go again. So the maximum sum that we are getting, we will be getting through Codey's algorithm, and then we will keep applying the effect. So the time complexity here, this fixing of these rows will be m times, like if there are m rows, and again we are going to each of the part would be n into m. So overall time complexity would be n into m square. So let's go and write its code. So for Codey's algorithm, I'm not going to write its code. I have already copied it. So let me paste it and then we will move ahead to code. So Codey's algorithm, I have pasted the code, but let's write the code for this. So we were making one array, Codey, and what would be its size? It was going through all of this, like it's like this. So its size would be number of rows. So let me find. So its size was number of rows. So number of rows are n. So I would update it with n. Like this Codey's matrix size is number of rows. Now what we were doing is starting from first this point, then this point. So I will run a loop. I is less than. So this is columns. So first column, then second column. So and c is equal to 0. Then column is less than m and column plus plus. So first we were fixing at this point, then this point, then this point. So this is that loop. Now after the column is fixed, I will start from this. Next time I will start from this. So j is equals to c. J is less than m. J plus plus. So why I'm doing it from j, not from I. So I will explain that one also. So let's see why we are doing j first. Earlier, what we generally do, we do I then. So how I want to move defines how which will come first. What I want to do from this point, I want to go down first, right? Then from this point, I want to go down first. So if you see, if I go down, what is my constant? Like what is, if I go down, what is changing row and what is constant column? So the column will come first and then row will come. Now every time for every row, if I'm starting, I will make my Codey is again new int because every time I'm starting, I want to start fresh. Like if I want to start from here, I want to start with this. Now, what I will do is update all, like keep some, do the summation, all of it in my Codey. So, KD of I plus equals to matrix of I comma j. So that if that is done, after coming out of this loop, I will I will check int Codey sum, like whatever Codey is getting me some, so I will apply this Codey in my array. In which array? This Codey array. And after applying the Codey, what I will do is I will create one answer for that I will initialize with 0. And if I say my Codey sum is greater than my answer, update my answer with Codey sum. That's it. In the end, return the sum. That's only thing we need to do in this problem. So let me compile the code. And it is passing. Let me, oh, there was some error. Now it is stuck. Let's find out. Okay, int m minus it is would be equal. So let me compile it again. Okay, it is saying return sum. I would say return answer. Now let us compile it again. Because here we are creating this answer, so we will have to return this answer. So it is compiled successfully. Let me submit it. And it is failing. Its correct output is -1. Okay. So it is failing because let me update my answer to some negative value. Then it would work because it is possible that it can have a negative sum as well. So if I update my answer to some negative value, it will work in that case. It is taking a lot of time due to it. So it got submitted, but okay. I hope you got the problem solution, whatever I have explained. If you got it, please like it.